All right, example 4. A rock falls from a high cliff. The position of the rock is given by y equals negative 16t squared, where t is measured in height in seconds and the height y is measured in feet. What is the average speed at t equals 2? Okay, so firstly, we need to think about what our interval is going to be. So we want the average speed as it's getting to 2, but if you think about height, I mean, you know that the interval is going to stop at 2. And where is the first height when the rock starts falling? That would be at 0. Okay? Or excuse me, I said that wrong. Seconds is time, right? So when the rock starts falling, it's starting at 0 seconds and going to 2 seconds. So it wants to know how long or how high it fell from 0 to 2. Okay, in 2 seconds. So to do that, we want to do f of 0 and f of 2. All right, so negative 16 times 0 squared is 0, and negative 16 times 2 squared is a negative 64. Okay. So then our a is 0 and b is 2. Then we can do our formula. So f of b minus f of a all over b minus a. That's going to be negative 64 minus 0 all over 2 minus 0. And negative 64 divided by 2 would give me negative 32. So feet per second is the rate here. So that means negative means it fell 32 feet per second. Okay? So that is your average rate of change. Okay? But what if we wanted to find the instantaneous speed at t equals 2, not the average? So at 2 seconds, what is the speed of the rock falling? That is an instantaneous value, okay? So we would be looking at the value closest to 2. However, we can't use the interval 2, 2 in our function because we would have 2 minus 2. We'd be dividing by 0, right? So we can't use that. We can't use our average formula, but, because we would be dividing by 0. But we want an interval that's 2 comma 2 plus h, so just a tiny bit above 2, and then we want to take the limit as h approaches 0. So we won't technically be dividing by 0, but we'll be getting very, very close to 2, okay? So by taking the limit as h approaches 0 of your function, okay, that's how we're going to find the instantaneous rate, okay? And it's not just the function. Your formula is below, okay? So, instantaneous rate of change. To find the value of a changing function at a particular moment, we use the same formula as the average rate of change on the interval, x comma x plus h, but we take the limit as h approaches 0. So we're, just like we've done before with a limit, we're going to take it to 0, and then we won't technically be dividing by 0 anymore. However, it still comes from your average formula. It's just adding a limit in front. Okay, because if this was A and this was B, and it was all plugged into the formula, you would get this instantaneous rate of change formula here. Okay, and so highlight that for your notes or star it so you always have that formula. Okay, so we're going to actually do the instantaneous rate of change from the same thing happening in example 4. Okay, so if you read the problem, it's exactly the same, except for your question is now, what is the instantaneous speed at t equals 2? All right, so our interval now becomes 2 comma 2 plus h. All right, that's your A and that's your B. Okay. Okay, and our function is still the same thing, so we need to find f of a, f of b, which is f of 2 plus h. And then we'll plug it all in the formula. Okay, so f of 2, we did already find, is negative 64. And f of 2 plus h is negative 16 times 2 plus h squared. Okay, so you could do that out and FOIL it right now if you wanted to, and then plug it into the formula. I'm going to just leave it like that and plug everything in and then start simplifying. Okay, so that's my a, this is my b, no, f of a, f of b, and then we have a and b right here. All right, so let's plug it into the formula. F of b minus, hold on, this is limit as h approaches 0 of f of x plus h minus f of x all over x plus h minus x. Okay, so you actually don't have to find the f of a and the f of b anymore. I probably shouldn't have done that. We can just go ahead and plug it in. All right, so f of x plus h we just found was right here. So I'm going to write limit as h approaches 0 of negative 16 times 2 plus h squared. All right, and then f of x, so it's minus, and then f of x was negative 64. So make sure you keep those signs together. All right, and then all over x plus h minus x, so 2 plus h minus 2, which obviously ends up just being h. All right, so let's simplify the top. Our denominator is h, but let's simplify the top. So this would be negative 16 times 2 plus h, the whole thing squared. If you FOIL it, would be 4 plus 4h plus h squared. Then minus negative 64 becomes plus 64. And that's all over h. Okay, now you have to times negative 16 to all of this. All right, which I would do that below. So now we're at limit as h approaches 0 of negative 64 minus 64h plus, no, minus 16h squared plus 64 all over h. Okay, now remember when you're taking the limit, your whole idea is to keep going, keep simplifying until you're not dividing by 0 anymore. And then you take the limit. So those cancel. And now there's a h in common with all of these. So if I factor, I will have h times negative 64 minus 16h. No, we took a h out. Okay, so yeah, that's what the rest of this factors to. If you take a h out, all over h. Okay, and now that those cancel, we can take the limit as h approaches 0, which would just be negative 64 minus 16 times 0, and that's negative 64. Okay, so that's the instantaneous rate of change at that point. All right, let's try a couple more so you can kind of understand. I know this is a little bit longer of a video, but I'm going to go ahead and skip the average speed so you can just see 2 more instantaneous examples. So let's do example 6. Our function is right here. Okay, a ball is thrown vertically upwards with initial velocity of 60 meters per second. After time t seconds, its height in meters above the ground is given as 60t minus 16t squared. Find its instantaneous velocity at 3 seconds. Okay, so our interval starts at 0 and goes to 3 for its seconds. Okay, oops. All right, and then our function is 60t minus 16t squared. All right, that's our function here. Okay. So it's thrown upwards with some kind of velocity, but your function is 60t minus 16t squared. So let's find, let's write the limit as h approaches 0 of f of x plus h minus f of x all over x plus h minus x. And again, you can just write h there. Okay. But we want, oh, excuse me, we don't need this because we're just finding at 3 seconds. Okay, I would need that interval for the average. So 3 is going to be really where we look at for the x, okay? So we're really wanting f of 3 plus h minus f of 3 all over h here, okay? And if you plug them into the function, that's what I'm going to do here. Let's see what we get. So equals limit as h approaches 0 of 60 times 3 plus h minus 16 times 3 plus h squared minus, okay, then I'm going to do f of 3. 60 times 3 minus 16 times 3 squared all over h. Okay, so I just plugged in everywhere there was a t. 3 plus h and then 3. Okay, you know what? Let's just ignore this example 7. I'm about to run out of room. So we'll just continue this and then that'll be it, okay? So there's a lot to simplify here. Firstly, when you're subtracting the f of 3, make sure you put the minus and make sure you, whatever this is, you have to change the sign because it's a minus. Okay, so let's simplify that first. This would be minus 180, and then 3 squared is 9. So 16 times 9. Hold on. 16 times 9, 144. Okay. So then the left side, we have 60 times 3 plus h. I'm going to distribute that and get 180 plus 60h. Okay. Then we have minus 16 times, now if we FOIL that, that would be 9 plus 6h plus h squared. Okay. Still all over h. So we're going to keep simplifying till those h's cancel. Okay. So 180 plus 60h. Now I'm going to FOIL the 16. So 16 times 9 is negative 144. Then plus 16, hold on. 16 times 6 is 96, but that's minus, sorry. Minus 96h. Minus 16h squared. Okay, then minus 180 plus 144. Okay. So then I distributed that minus. As you can see, obviously your numbers should cancel, or there's no way we're going to be able to take the limit. All right. So now we're at 60h minus 96h minus 16h squared all over h. Okay, combine those 60 minus 96. So negative 36h minus 16h squared all over h. Cancel your h's. Okay, so now we're at final thing here. Limit as h approaches 0 of negative 36 minus 16h. So plug in your 0 here. And that's negative 36. Okay, so that's it. We may try the next one for a warm-up. If you have questions, please star this problem and we can go back over it in class.